Hello, everyone. Here's teacher Dilan and my partner, teacher Iván. And today we will present you a class about the sound behavior. So let's start. Okay. The objective for this class and for the entire unit will be explain the sound behavior using the wave model and experimentation. Okay. In this class, we will explain little things about the sound, try to remember the characteristics, the the properties of the wave, and try to relate to the sound. Okay, and so in some previous classes, we see that the waves have different characteristics. For example, we have the longitudinal wave, the mechanical wave, electromagnetic wave, etc. So the sound is a wave, and like it's a wave, sound have a behavior like a mechanical wave because sound needs a medium to propagate. Okay, so because the sound needs a medium to propagate, the sound has a mechanical behavior. Okay, in this medium could be the air or gases, the solids or liquid. Okay, and in each medium, the sound will have a different speed of propagation. Okay, so, so propagate like a mechanical wave, sound requires a medium such as air, liquid, or solid to travel. Like I say previously, the sound it has a longitudinal wave behavior. What what that means? A longitudinal behavior means that the vibration of particles are in the same direction that the wave movement. For example, if the particles are vibrating like this, left and right, the propagation of the wave movement or the wave movement will be or maybe or left or to the right, but will be propagate like this. Okay, and like I say before, the speed that the sound will have depends of the medium that is propagated. So the in the solid, the speed of the sound will be higher than in liquid or gas. Why? Because the molecules that have the solid are very close to each one. Okay, they are very close. So if the sound vibrates, the particles obviously will um, vibrate with the movement of each particle. And if they are close, the sound will be propagated with more facility. In case of liquid or gases, the molecules are they have a distance between them. So it's more difficult to travel. It's more difficult to propagate. Okay? Okay. We know that a sound is a wave. And because of that, the sound has also the characteristic that a wave has. For example, the wavelength, the amplitude, the frequency, and obviously an speed. The wavelength will be the distance between the two um, the two maximum points of a wave, like we see. like we can see here in these two maximum points, like the amplitude is the amplitude, these 2 points, and the distance between these 2 points uh, is it's called the wavelength. The amplitude will be the maximum point that a wave will have. The the frequency is the number of waves that pass a point per unit time. What this means is the number of cycles that a wave has. Okay? And the speed is what wavelength a speed can travel in a period of time. Or in another way to obtain the speed is the wavelength um, the wavelength time travel. Okay? They are they are related, the frequency and the period for obtain the speed. Okay? But the formula we will see in another class. Okay? So let's continue with the sound characteristics. The sound have three different characteristics: the intensity, the tone, and timbre. Okay? Sorry, sorry. Here, the intensity. The intensity of the sound is how higher or low, sorry, how higher or lower the sound will perceive, will be perceived. It is related, the intensity of the sound is related with the amplitude, like we see here in the picture. Low amplitude will mean that the intensity of the sound will be low. And high amplitude, here the maximum points are bigger than the previous picture, the intensity of the sound will be high. Okay, the next, the next one, and the tone. I'm a little sick, but I'm here to the class. Tone. The tone is how high or low a sound is. The tone is related with the frequency of the sound. If the sound has high frequency, it means that have a lot of cycles of the wave. The sound we will hear more. um, my neighbors are a lot of cycles. Um, but just like I said, a high frequency, it means that the sound is high. And a low frequency, it means that a sound will be low. For example, an example you can for you can understand, a high frequency will be, and a low frequency will be, oh, okay? Yeah, that is the difference. And for the last one, the timbre is the difference that we can see in, in a source of the sound. What that means? If we have a sound with a same intensity and the same tone, so we can identify that what source of the sound is for the timbre. The timbre is a special characteristic that have the source. For example, here are four instruments or four different kind of source, sources, and they are playing the same note, right? But if you can see the graphic, all the graphics will be different for the same note, okay? And how we identify that some have special characteristics is because the timbre also um, is useful to explain why the people have different um, different voice. Okay, and now I let you with my partner, Teacher Iván, so they can explain the last part of this class. Please. Okay.
The sound, like a wave, have properties that explain its interaction with the environment, such as reflection, refraction, and diffraction. Each one will be explained below. The reflection. The reflection is present when a sound have encounters a surface, it's bound back, as we can see in the diagram. We have the sender or the receiver and the object, and the wave are reflected. The next one is the refraction. The refraction of the sound is the change in direction of a sound wave as it passes from one medium to another. In this case, we have two mediums. The first one is the air, and the second is the water. And when the wave pass to one to another, the speed of the wave change, the speed of propagation, and that produce an change in the direction of the on the propagation. The last one is the diffraction. The sound diffraction is the bending of waves around obstacles or through openings. We have two two scenarios. In this case, the scenario A is a large wall barrier with circular opening, and this is the behavior. How can we see? And the second is uh, a sound propagation in a corner that produces this behavior. In conclusion, the sound have a wave behavior with characteristic and properties that allow us the communication, and it is a physical phenomenon that we study to understand the universe behavior. Thank you for your attention.